All right, the last one. Again, I'll get you guys to try it first. All right, so here we got our initial question. We got our lighthouse at O. Our initial point P, which is obviously not to scale on here because it is 31 kilometers west and 32 kilometers south. It's moving parallel to the vector 4, 3, 4, 3 at 20 kilometers per hour. An hour leaving at the ship is at point R. So write down the vector O to P. Well, if we're at 31 kilometers west and 32 kilometers south, the point P actually would be down there, and its position vector would be 31 in the negative direction here and negative 32 down there. Now in part B here, it's asking us to show that the path ship can be represented by this equation. So it's not enough to show that this equation works. We need to come up with this equation. So in order to come up with our equation, we need a point that we're starting with. And we know that point P, it starts at negative 31, negative 32. Now since it's going in the direction 4, 3 with a speed of 20 kilometers an hour. Right now, if we look at 4, 3, its length is 5. Because if we do a squared plus b squared equals c squared, its length is 5. So our velocity vector, since we know that our velocity is 20, this vector would need to be multiplied by 4. 4 times 4 over 3, which will give us 16, over 12. And now that we have our velocity vector and a point to start with, we can say that the vector equation of this line is negative 31, negative 32 plus t, 16 and 12. So in this case, it's not enough to take, the tempting thing to do in this case is to take what we're given and show that 16 squared plus 12 squared happens to equal 400. And the square root of 400 is 20. So we say, well, the speed is 20, and therefore it's parallel. Since 1612 is parallel to 4,3, it's the right way. The unfortunate thing with that is you're using the answer to show that it works. And in a question where it's asking you to show something is true, what you have to use it and then come up with what you want to show, rather than start with what you're supposed to show and then use that to show it, because it's sort of a circular argument then. So here, we took the stuff that we were given. We knew that it was going in this direction, 4, 3. We knew its speed was 20, so we knew we had to multiply it by 4. And we came up with 1612, rather than starting with the 1612 and showing that it worked. Find the vectors from O to R and P to R. Well, we know that point R was when you traveled 1 hour. So on our vector equation of a line, we started with negative 31, negative 32. And if time was 1, we get that the position of vector R would be negative 15, negative 20. So there's the position vector. This is O to R. Now, if we wanted to go from P to R, and we want to use our position vectors, well, we've got our O somewhere here. If I want to find the vector from P to R, I've got to go from P to O and then O to R. So that would just be negative P plus R. And it's not surprising that we get 1612 because that's how far you would have traveled in 1 hour, because that's your velocity vector. Show that when the ship reaches R, the lighthouse first becomes visible. So we've got our vector OR. What we're going to show here is the length of OR this is going to be is that right? Those are the there we go. Something seemed a little bit off. 225 plus 400 is 625, which means that it is exactly 25 away from the lighthouse, and that was the radius at which the lighthouse could see. So because its distance is 25, it could see it at that moment. Or is it right in the middle of the ship? I guess we'd have to determine. Maybe it's right where the captain is driving that they just a little. Yeah, so I guess it depends on maybe this is your ship. Ooh, this is the prettiest ship I think I've ever drawn. I like it. And it's a mixture between a tugboat and a Viking ship where they have like the thing here, and there's of course the golden banana at the front. And that golden banana just barely becomes visible at that moment, if the golden banana is what you used as your measurement. Uh-oh. Second ship with a monkey at the front. Has this equation, will the boats collide? Well, we'll have to find out. So here's our parametric equations. And did I write those in the right order? Is the 1612 right? Okay. So now if, again, the t is the same thing, so using our first equations here, -7 plus 10t equals -31 plus 16t. We're going to get 6t equals 24, so t is equal to 4. It's a good thing we didn't make a question where time was negative. So they're safe at this moment, but 4 hours ago they had collided. And the second one, now we're going to see what happens if 4 plus 3t equals -32 plus 12t. We're going to get 9t equals 36, and that implies t is equal to 4 again. So the monkey gets the banana, and everything is happy. Yes?
But this only is true when like cruise ships would always travel, right? They could also be that one trip takes 5 hours, another ship only takes 2 hours, and then waits 3 hours.
Well, this is based on these equations saying that these ships are traveling at a constant speed in a constant direction. They're not changing their mind at all. They're like, oh, there's another big ship out there. It's getting closer. We're driving right for it. Should we change directions? No. We were given the following vector equation. We must stay. And then they collide. Well, in this case, because the time t is given as the same parameter, then we're saying at time 0, this ship is at -7.4. So that means 7 kilometers to the west and 4 kilometers north. and the other ship was at negative 31, negative 32. And since the parameters are the same, then that's based on time equaling 0 at that point. And then looking forward at t equals 4, they will be at the exact same spot, so they would collide. If you're looking at different things happening at different times, then you need different parameters. One would be t and one would be s. And then you would have to do a comparison there. And then there would be two equations with two unknowns that you'd have to solve.
But we also could do it here with two unknowns, and then we wouldn't have, then it would work automatically.
If we put t and s here, it would still come out, but you'd have to solve for what t is and what s is, and you'd still get that collision. So there it is. So we already have 13E, and I think I gave you the review already as well.